All right, so comedy time is over. Now it's time for some serious Gradle learning. And with that, thank you very much, everyone, for joining us. I hope by the end of this talk you can learn a little bit more about how hard the build team has worked to make sure that our tools are working hard for you so you don't have to. We're all from the Android Studio team. My name is Adarsh Fernando. I lead documentation.
My name is Izabela. I work on the Android Gradle plugin.
My name is Amar, and I also work on the Android Gradle plugin.
And my name is Maksim. I work on Android Studio.
Cool. So in previous iterations of this talk, we usually go over a bunch of cool tips and tricks that you can go and try at home, or even from the audience to speed up your builds. But you know, once we started learning that the more the build team kind of worked to build in these optimizations, there's a lot of these either you didn't have to do anymore because the plugin did it for you, or it was unnecessary because we had something smarter. For example, you didn't have to use multi-APKs because we have app bundles. We disable PNG crunching for debug builds, even though WebP is great for runtime. And filtering resources when you're deploying using Android Studio, well, it already only pushes the resources required for the target device. So the biggest takeaway that we're going to try to express is staying up to date is the best thing that you can do for your project to optimize your build or just to make development more delightful. So whether you want to go on a fully tested build, which is stable, 3.5.2 is our latest, a lightly tested preview, which is beta, or our bleeding edge version, which just released yesterday, Canary 4.0, Canary 1 of Android Studio 4.0. Let's just see a show of hands. How many people are on 3.5 and higher? Okay, how about 3.6 and higher? Keep those arms raised. 3.6. Oh, and who's brave enough to be on Canary 1 4.0? Okay, hopefully we're going to get some more arms raised afterwards. So really, this started with 3.5 and what we called Project Marble. It's when the team took a moment to pause on shiny new feature work and really focus on three pillars, which is system health, feature polish, and bug backlog. So really just make it a healthier IDE for our users. So here's a graph that kind of illustrates how this happens. So in earlier versions, the graph above is our average build time, and below is our median deploy time. So in earlier versions of Android Studio, we saw an upward trajectory in both. And this wasn't because our tools really got slower. It was just that there were more features being developed, and your projects just became more complex and more modern. So we tried some things to kind of arrest that trajectory, but then 3.5 with Project Marble is really where we saw a decline in build speeds and deploy times. So just to give you some numbers, before and after 3.5, for build times, we went from 12.5 to 9.5, so roughly 25% drop there. By taking advantage of some modern architecture on the latest versions of Android, we were able to bring deploy times by 50%. So using things like apply changes was clutch there. And if you haven't tried that, I really encourage you to do so. So the first area that we're going to talk about is incremental annotation processors, which is kind of a big deal when you think about it. So a lot of you probably use APs just because why would you want to recreate boiler code and write the same code over and over again? But having a single non-incremental annotation processor in your project actually makes all of incremental Java compilation not work. So what is it non-incremental? So really, a non-incremental annotation processor is one that doesn't define its inputs and outputs. To Gradle, it's like a big black box, right? So it doesn't really know what the annotation processor needs or what kind of files it's going to produce. So it's unable to appropriately scope the amount of work for that annotation processor. So an incremental annotation processor, has to actually identify what the inputs and outputs are. And it also has to register with Gradle as an incremental AP, either as isolating or aggregating. So isolating is probably the most clear-cut. For each source file, it's going to output one file. But you can also have aggregate, where you take a bunch of annotations, process them, and output one or more output files. But really, what does this mean for you? Well, when you're using incremental annotation processors, there's less recompiling, so that means faster builds. But like I mentioned, there is a catch, right? All your annotation processors must be incremental, or there's no incremental Java compile. And that's basically because if there's one non-incremental, Gradle has to assume that that annotation processor just needs to have all the source code recompiled. So what the team did was we targeted the top 10 top 10 annotation processors to make them incremental. And as of last month, we were successful in doing that. So a lot of these APs are produced by us, so obviously we felt we needed to make those incremental, but we also worked with external developers to help them make their annotation processors incremental as well. Another area that we worked hard on, which is very impactful not only to you as developers, but also to your users, is the app bundle dynamic delivery space. And we've introduced something in 4.0, which is called feature-on-feature dependencies. So just to kind of provide some context, app bundles are where you compile your code and resources into a single artifact, and then you upload that into Google Play. And what Google Play does is then repackages your code and resources and signs them so that users only download the code and resources they need to run your app. So for you, it's a lot less managing artifacts, a lot less things to build. You don't have to build 120 different multi-APKs. You just build one artifact, and your users get tailor-made APKs. So part of that benefit is dynamic delivery, where you can modularize your app and into discrete features, and you can have certain features that not all of your users may need at app install and have that download later on demand. So here's an example where we have features for taking pictures in the camera and a module that allows you to take videos, and maybe you have something to take care of payment transactions. The camera and video are pretty similar. They probably require similar dependencies. And so what you're doing here is you're kind of repeating a lot of the dependencies between the two modules, and your users have to download, who want to use camera and video, are having to download two separate modules. You could combine them, put camera and video into one, share those dependencies, but then you have this larger module, and it kind of defeats the purpose. So what we've introduced is feature-on-feature dependencies. Now video can depend on camera, which depends on the base module. So what happens is your users who just want to download the camera module can do so. And for those who want both, well, you can just request to download video, and there's a level of guarantee that the dependencies in camera will also be available. So you have that additional level of flexibility there. And just remember, when you do set this up, your base module needs to also be aware of all the dynamic features that are available. So to dig a little deeper on some of the stuff that we're kind of doing built in to optimize your build, I'm going to pass it over to Isa.
Right, so today I wanted to talk to you about the cool improvements we've done to the resources pipeline in the last few months. First, I wanted to talk about the light R classes. Some of you might have already heard of it, as we've done this already in libraries in 3.3. The main idea behind this is that in older versions of the Gradle plugin, we would wait for apt to generate the r.txt file, which contains a list of resources. Then we would generate r.java from it, and only then call javac to compile it into the bytecode. Now, what we do, instead, we take the r.txt and generate the bytecode directly using ASM. This not only means your build is faster, since there's less stuff to write and compile, but also the experience in the IDE is much better, since the IDE doesn't depend on the sources anymore. It looks at the r.txt, and so syncing and indexing is also faster. So like I mentioned, this was already supported in library modules in 3.3, but now starting 3.6 is also supported in app modules. The next thing I would like to talk about is the R classes, how we generate them. So previously what would happen, the leaf libraries would each generate its own R class, of course, but then when you have a library that actually has some dependencies, what happens, this library generates its own R class, but also an R class for every single dependency it has. And the same thing happens at app module. So it might not look like much here, but once you have 100, 1,000 modules, some people do, that's a lot of R classes. This easily leads to a quadratic number of R classes in total, which isn't great. So what we started doing in 3.6 is using compile class path R class flow, which is a mouthful, but what it means is that we started reusing the R classes from libraries. So now A, B, and C still generate their own R classes, but library 1 doesn't regenerate them. It reuses those libraries, just puts them into its own compile class path, and so there's no need to regenerate them again and again and again. We still need to regenerate them only in app modules, because that's when we get the final IDs, the IDs that are used at runtime. So that's why we need to regenerate them there. But we can improve this even further. So there's an experimental feature that we added. We call it the compile time R classes in app modules. What this means, we start treating app modules as libraries when it comes to resources. So in order not to wait for the final R classes for Java C and Kotlin C compilation, we actually generate a mock R class similar to the library. It contains mock IDs, they're not final, and generating this compile time only R class can take as little as half a second for medium-sized projects, while the full pipeline for getting the final R classes after compiling and linking resources can take several seconds, like 4 or 5 seconds. So it's almost 10x improvement here on reducing the length of the critical path here. There's one catch. Because we would be using non-final IDs in app modules, this is a source-breaking change, because you cannot do switch statements anymore if the IDs are not final, and you cannot use them in annotations. That's why this is behind a flag. So if you want, you can experiment with it, but be aware that you might need to do some changes in your source code. So let's also talk about the contents of the R class. When you're developing your library or app, you might have noticed that when you reference a resource, let's say from the support library, you can actually use your own R class. This is because resources get merged and put into the R class at every single module. So the local R class contains both the local and dependencies resources. This leads to really big, bloated R classes. For example, if you create a simple Hello World app, even if you have only 5 resources in that module, that R class will have over 2,000 resources already. So that's pretty big. So to battle this, this is another flag. We call the namespaced R class or non-transitive R class. What this does is in library modules, the R classes will only contain its own local resources, greatly reducing the size of the R class. So not only the R classes will be smaller, but because there's less to write, the build speeds will be faster as well. And again, this is also a source-breaking change, because then you actually need to keep track where the resources come from. So you need to start using the packages or namespaces of the resources. So if you want to use a resource from the support library, you actually need to use the R class for the support library. Next. So let's talk about the resources themselves. So the way, as I mentioned, the resources are handled is that, for example, for release builds, what would happen, they would need to be remerged and recompiled at every module. So here, let's assume we were doing a release build. What would happen, resources from lib.a would be compiled and linked at library A level, but also remerged, recompiled, and relinked at lib1 level. And again, at each of the consuming apps, again, remerged, recompiled, relinked. So this is a lot of redoing the same thing over and over again, unnecessarily. So in 3.6, by default, we started pre-compiling those resources. What this means, each resource will only get compiled at its own module, and these compiled files later will be provided to other modules so they can be reused between modules. It gets even better because we do the same thing for AARs and transforms. So for example, if you reuse support library between different projects, that will only be compiled once, and you will get the benefits in the following builds as well. It can be reused between projects. Yep. So to sum up, we have these benefits in 3.6. We generate the bytecode directly, both in library and app modules. We only generate library R classes once in each module and reuse them. And we precompile resources. You get these three for free just by upgrading to 3.6. And if you want to experiment to speed up your resources pipeline, your builds even further, you can use the two flags that I mentioned to use compile time R classes in app modules, or to use namespaced R classes in libraries as well. Cool. And now, back to Adarsh.
Thanks, Iza. So we talked a little bit about some optimizations that we do and that you get for free. I want to talk about a couple of things that we've done to just make development and using our tools more delightful. And here's something that I know like a lot of people have asked for, and it's Kotlin DSL support. So we do support KTS files now. And with that, you just get better IDE support due to the statically typed language. So things like code completion, quick look at docs, you can even run lint on your build configuration. And it's fully interoperable with the project structure dialog. So what that is you can manage your dependencies, update them, create build flavors and build types, all without even touching your build script. And it now works with KTS as well. So here's a quick look at that. As you can see, like in the default block, the default config block, it shows you all the different kinds of elements that you're able to configure there. And when able, it provides you documentation so you know you're using exactly what you're meant to be using or what you intend to use. Java 8 desugaring is something we've also worked, the R8 team has worked hard on. And it's not something incredibly new. I mean, Java 8 desugaring was available for the more modern Android platforms. But what we're doing now is pretty cool, and it opens it up for regardless of your API that you're targeting. So what we do now is we desugar Java 8 language APIs and package that desugared library in with your app. And so what D8 does is it kind of rewrites your code a little bit to instead of point to those Java 8 libraries, but point to the backported version that's packaged with your APK. So that it is available despite whatever API level your app is running on. So here are the APIs that are currently available on Android Studio 4.0 Canary 1. We really encourage you to try it out, communicate, contact the team, file bugs if you feel like some APIs that you really want are missing. And the team is very open to working on what you all want. It wouldn't be 4.0 with some breaking changes, so there are new Gradle APIs, but the good news is it shouldn't affect most app developers. It's really for plugin developers. So just a little bit of context, the old Gradle plugin really, what it did was it exposed the tasks that it used to build your app. And that essentially served as the API. So plugin developers would hook it in right into the tasks, call them, use their inputs and outputs to customize the build system for them. But what that did was, it required them to juggle tasks, like know when certain tasks run and when that output would be available for them to use. But also, it kind of made the build team work with their hands tied behind their backs because we couldn't refactor tasks, we couldn't combine or remove them because that would break plugins. So we couldn't do a lot of improvements we really wanted to, at least not without breaking your builds. With the, going forward, we're actually basing the plugin on new Gradle APIs. And what you really want to understand here, or take away from this, is that there's a bigger focus on the actual artifacts that we think are useful to plugin developers. So it's not about how or when those artifacts came to be, but the artifacts themselves. So for example, if I was writing a plugin and all I really cared was about the merged manifest, I just have to declare a dependency on that artifact. And Gradle will take care of the task dependencies. They'll take care of when my task should execute based on when that artifact is available. So that makes it a lot cleaner for the build team as well, because they can work on under the hood and change tasks and improve them as needed without breaking people's plugins. So I did this during rehearsal too. I skipped ahead a slide. So the biggest tip that I would give to you if you wanted to know more, there's a great talk at ADS from the leads who are kind of migrating us over to these new APIs. It's called From Gradle Properties to APIs, and I encourage you to take a listen to that talk. So we've talked a lot about optimizations and things that work for a large number of projects, but each project is quite different. And to talk about some of the more investigative tools that we're developing to help you tinker with your project, I'll turn it over to Amr.
So from our user research and studies, it's almost always been the case that one of the top priorities for app developers is build speed. Users always want shorter build times. And with the build team, continuous improvements to the build system and all the features in the build system, we wanted to have a tool that could provide us information and help us identify the bottlenecks in the build system. And also, not only do that, but also show the users where exactly their build is being spent. That's why we came up with Build Attribution tool. So basically, Build Attribution is a tool that breaks down the build for you. It shows you exactly where the build spent, which plugins did run, which tasks did run, and why these tasks did run, and other things that Maksim will talk about in details. So it doesn't only show you where the build is being spent, but also it tries to find potential issues or problems with your build that are blocking your build from being faster. And if this problem could be fixed from the user point, then we suggest a fix so that you could fix this problem. If it's like a problem in our code base or from a third-party plugin, then we encourage you to file a bug against them, and we provide you with details that would be useful for the plugin author to exactly know the issue and how to fix it. We also provide links to documentation for each issue so that you could learn more about it and know how to avoid it while designing your plugin. So one thing we don't want to do while designing this tool is, basically this tool is for improving your build speed. We don't want it to affect the build speed. So one of the top priorities we had while designing it is performance impact. So basically the build attribution tool runs as a part of the IDE build. It's unfortunately for the first version, it's not available from the command line. So this tool runs in two phases. The first phase is basically data collection. So while the build is running, it will collect data about tasks, transforms, plugins, basically everything in the build. And then after the build is finished, it will run some analyzers and find some issues with the build, and then build the UI. So we did some benchmarks after the implementation, and it showed that it has an overhead of less than 1%, and those benchmarks ran on different projects. Some of them had up to 100 modules, which means thousands of tasks. So yeah, it's very good. And now to Maksim with the live demo.
Hi. So here I have built our Santa tracker app, slightly modified, and we see that it took 45 seconds. But how do you know, like, what can you work on to improve the speed? So with our new tool, each build will generate a detailed report to help with this, and you can see it on new build speed tab. And first thing you can see here is a report about critical path. Critical path is like the longest path of tasks executed sequentially. So if you want to improve your total build speed, you need to first of all focus on these tasks. You can view it like task by task, or here we have grouped it by plugin to see the cumulative plugin impact on the critical path. And so first thing we see here is that like one of the most significant time impact is from licenses plugin, from generate licenses task, and we know that this task generates license notices for all your dependencies, and you want it for your release build, but you most probably don't want it for your debug builds. So what you need to do is to configure your build in a way that this plugin applied and this task runs only for release builds. So let's say that we did it properly and turned it off for their debug build. Also, you can see here some issues found and associated to this plugin, but let's look at all the issues grouped by its type. First of all, we report always run tasks, and for each issue, we have a brief description, a link to documentation, so you can learn more about what is it and how to fix it. We provide like some crucial information about the task itself and like help with instructions, link to instructions to how if you need to report it to plugin developer. And so this issue is about this task declares no outputs, and so because of this, Gradle cannot detect that it's up to date, so it cannot run incrementally. And it cannot be detected up to date and skip it. So it has to run on every build, and then some other task may depend on it and also run on every build, and that's pretty bad. But this task is from the plugin we already fixed, so let's move to another one. This task also always runs, but for a different reason. It overrides its up-to-date check to be always false. Some plugins do it maybe for their reason, but you should be careful about it. You should know about it, and because again, it means that these tasks will run on every build, and it may trigger some other tasks to run. For example, this one we know is from Crashlytics plugin, and it generates build ID for each build, and it makes like resources compile, remerge, so lots of extra work for each build when you effectively need it again only for the release. So you need to again go and configure it in a way that it doesn't run on debug builds. Also, what we report is configuration issues. For example, here we see two tasks that define the same output folder. And again, because of this, Gradle cannot be sure the task is up to date, and it has to run it on every build. And one of the tasks is actually Java compiler. So now we have Java compiler running every build and triggering everything else to run every build. That's pretty bad. And you need a way to detect it. So now you know about it, and you can find like our second task that does it, like this one, and reconfigure it. So let's see. Yeah, here indeed we defined output dir the same as Java compiler. So we need to fix it. And so yeah, if you can reconfigure it, you need to find a way to reconfigure it. If it's not configurable, it's a problem in the plugin, you have to go and report it to the developers. Also, we report non-cacheable tasks. That's the tasks that are not annotated as being cacheable. And if you want to benefit from Gradle cache, local or remote, you need your tasks to be annotated as cacheable. Plugin configuration time, as you probably know, before running any tasks, Gradle has to configure all the plugins. And normally it takes, it runs for every build, even if actual tasks will not be executed. But usually it's normal because it should be very fast. But some plugins may, by mistake, include some heavy computations there, and then it will be a problem for every build again. For example, here we see that configuration for one of the projects took more than 2 seconds. It's kind of a problem. So if we go and see where it comes from, we see that there is some slow plugin defined. And so we look for it, and we find that this plugin does indeed very heavy computations on the configuration phase. So yeah, need to move those computations to later phase, to like task execution phase normally. And what else do you do? No, what else we report is non-incremental annotation processors. As Adarsh said earlier, you want to move to incremental annotation processors if you want incremental compilations. And so you have to know if you use any of non-incremental versions. How you do it? Usually you move to latest versions of your incremental processors. So here we have them defined, and we move to latest versions. And after you had like applied fixes, you rerun the build and see what happens. So to go over again, what we see is like we now better understand what makes up the time of our build. We know if you have any issues, if you have any non-incremental annotation processors, if we have any non-cacheable tasks, and then we can work on it and improve our build. So also worth mentioning that it's an iterative process, because after you fix something on one critical path, you may have another critical path, but that's the thing, it's an incremental process. You need to improve and improve your build every time. And so we have now another report with another critical path, with issues fixed, but there are maybe some other warnings and stuff. But now Amr will also talk about the other native build attribution.
We also added support for native build attribution. So if you don't know that already, in EGP we have a tool to visualize your build and know exactly what happened during the build. You basically add this flag, enable profile JSON, to your Gradle build, and then EGP will produce a file in Chrome tracing format in project directory /build/Android profile. If you open this file in Chrome tracing, you'll find a view like this. Not sure if you can see, but so basically you have a timeline of the build. Each block or slice corresponds to an event in the build. So we have artifact transform, Kotlin compilation tasks, Java compilation tasks, and lots of other things. You can have like Java threads or Gradle workers. So this already existed for a while in EGP. We also added support for native builds. So if you look at the first 4 sections, you can find native builds for different targets. And each slice also corresponds to a native build event. So for example, here we have a compilation event for a file called monkey to CPP. So basically, you can find from here how long did it take this file to compile, and if it's linking, how long did it take to link those files. Also, you can find the exact arguments that were passed to this event. Okay, so from this view, if you're having troubles with your native builds, if it's too slow, you can look at it. If you're, for example, you're expecting your native build to be done in parallel, but it's actually sequential, then maybe there is some misconfiguration happening. Also, if there's like one file that takes a long time to compile and it blocks other files from being compiled, maybe you can break it down to smaller files and get the benefit of parallel compilation. Yeah, so this will exist in 3.6. It's already there. You can try it out. I mean, the native build attribution. The build attribution tool is not ready yet. It's not in 4 or Canary 1. It should be there soon, so stay tuned. And now back to Adarsh.
Thank you, Omar. So, so we thank you very much for attending the talk. We talked about the Project Marble and how that really helped boost or actually reduce the average build time for 3.5. We talked about some of the features that we've added in 3.6, like new resource pipeline. And then we talked a little bit about forward-looking, the bleeding edge features that some of which landed yesterday and some of which are going to land soon, such as the build attribution. So we really encourage you to keep your tools up to date, and keep in mind you can have stable version of Android Studio and the Gradle plugin live side by side with the preview Canary version of the plugin. So definitely give it a shot and give us feedback and let us know what you think. With that, thank you very much. Yeah. I think we got a little bit more time, so if there are any questions, we'll be happy to answer. I think there's a microphone. Sure, I think someone's coming with a microphone, someone right in the middle there.
Thank you. I actually have a few, so I'm going to prioritize them. You mentioned that you are going to remove the combining of the libraries, so it's going to be one R5 per library, right? Is that a change that's going to happen, or is because it is experimental now? But let's say we want to try it, and we will need to rewrite the whole code. Or maybe they replace the resources from the other libraries in the main code.
Hello? So there were two changes. One, that generates one R class per library. That R class that's generated will still contain all the resources from the dependencies. So it's still the big bloated R class, but there's only one. So that reduces the number of R classes from n squared to n. So that you get for free. That you don't have to worry about, you don't have to change anything, it should just work. The second thing that you also mentioned, the namespaced R class, so the smaller R classes, so the ones that contain only local resources, yes, that will require refactoring. There might be a tool in the IDE to help you with this in the future, but for now, it's something you will need to do on your own.
Yeah, but my question is, if we do that, we change the places where it doesn't compile, and then we remove the flag because we find some issues, it won't break the code.
No, so that will still work because each class, so our class for each library contains its own resources and dependencies. So if you, in your library, try to reference a resource from support library using its support library R class, that R class is still in the class path of your library. So the one that we generated for the support library, it is in the class path. So you can, so if you do that refactoring, it will still work even if you turn off that flag.
Great, great. I have another one, if I have time, someone else wants to ask. You mentioned that we should add cacheable to the task. I don't recall who did it. I think
Both were talking.
Isn't the input and the output declaration is not enough for being cache?
No. So basically, you need to specify that your task is actually cacheable. So there's an annotation called cacheable task. So this cacheability check is not up-to-date checks. It's a different thing. For up-to-date checks, yeah, you only need inputs and outputs.
Okay, so cacheable is something else. It's to
yeah, it's when like the daemon dies and then you restart a build. If there was, Gradle can basically fetch the outputs of the tasks from the cache.
Okay, great.
Or even like from remote on. Yep.
Thank you, guys. I have a really important question. Could you open transitive R classes slide, please?
Don't look too much at the screen right now.
Yeah,
This one?
that's it. Yeah.
Yes.
So in the app block we have heart. So, but in libraries not. Does that mean that we should that libraries should be written without heart?
Sorry, I was running out of shapes. So what I wanted to represent is that the heart is the is the resource added at app level. So that's why it's not visible in the library, because it was added at app level and app depends on the library.
Yeah, got it. Thank you for that speech.
Sure, thanks. Any other questions? We will also be here by the stage if you just want to talk to us without the microphone, and then we'll also be at the Google and Android booth in the hall later on. Thank you for your attention.